I want you to remember that we have all these physiological variables that we have to maintain within a particular range of the what point. And you guys know if we have a deviation from the set point, that's not necessarily a bad thing, but we have a word for that. We call it what?
Stress.
Stress. And so what happens, of course, in order to maintain health, if I have a deviation from the set point, I need to bring it back up to the set point. And so what's going to be out there is I'm going to have some sort of a what, everybody? Right, receptor. Say receptor. Okay? And the receptor is going to pick up, particular type of stress. It could be high blood pressure, low blood pressure, low oxygen carrying capacity. It could be body temperature. There's just, blood glucose level. There's all sorts of receptors, chemoreceptors, osmoreceptors. We've talked about so many of these things over 2 semesters. So whatever it is, the receptor is going to pick up that information and convey it via what pathway? Afferent pathway to a what center? And then the control center is going to be the control center is then going to be looking at that information, comparing it to a genetically predetermined what point? Set point. Okay, the genes will determine that. And if we do have a deviation, then what's going to happen is the control center is then going to be sending some information via a what pathway? Efferent pathway to some sort of a what?
Efferent control center. Say
effector. Effector. And the effector is going to do something, or in other words, it's going to have some sort of a what? Effect. The effect, of course, is to what? Restore homeostasis. Okay, and of course, we're dealing with a negative feedback system here. So in AMP1, we took a good look at the nervous system. And in the nervous system, of course, the control center was, dealing with neurons. The afferent and efferent pathway were dealing with neurons and nerves and that sort of a thing, cranial nerves, whatever. But now what we're going to do is we're going to look at another aspect of this, where the communication is not going to be nerve impulses, but it's going to be chemical messengers. And the chemical messengers are called hormones. Alrighty? And so in that particular case, what happens is that you're going to see oftentimes the afferent and the efferent pathway is not going to be nervous, it's going to be the bloodstream. And what's going to be transporting in the bloodstream are these chemical messengers that will now communicate between, receptors and effectors or whatever. So far, so good? Okay. And so what happens, of course, is these hormones tend to be very, very specific. And so once if the control center secretes, for example, if the pancreas secretes insulin, okay, the insulin goes into the bloodstream. We've talked about that in AMP1. And then eventually it's going to go to some sort of an effector. And of course, in AMP1, it was the liver. You might remember that was your very first lecture. If you don't remember, don't worry about it. What the liver is going to have, it's going to have special insulin receptors. Special what, everybody? Insulin. And what we note is that those receptors are highly specific. And so the particular tissue that has those receptors, we would call that the target tissue or the target organ. Okay? And again, these are highly specific receptors for very specific hormones. This is a highly specific system. So far, so good? So basic functions is, of course, when we're dealing with a negative feedback system like this, of course, it's to maintain homeostasis, to keep all the physiological variables within a narrow range of the set point. Has regulatory functions, so for example, growth. AMP1, we talked a little bit about this, but little Johnny's growing like a freaking weed, isn't he? And so that's controlled by my hypothalamus. And so what will be secreted is a hormone called growth hormone. We'll talk about that tonight a little bit more. Reproductive matters. And again, so much of that, which you guys saw with the male reproductive, and again, you're going to see as you continue with the female reproductive system, but those are driven by hormones, okay? And so really, really important. So far, so good? All righty, look on your sheet. I'm going to talk a little about the chemistry of some of these hormones. And what we have is a lot of classifications. And you ought to appreciate this because you'll be dealing with, in pharmacology, you're going to be dealing with glycoprotein steroids, protein hormones. There's all sorts of different types of proteins. And depending on what the classification of the molecule is, it may be that you cannot ingest it. Sometimes you can ingest it. But if you can't ingest it, for example, if you have a hormone such as insulin, which is a protein, I can't take that orally because it's going to enter into the stomach, and of course, what is the function of the stomach? Is to begin to break down proteins. Do you guys follow? And so that's impossible. We'll destroy the hormone. So what we have to do is to go bypass the digestive tract and we put it directly into the arm. Do you guys see it in the bloodstream? So the first classification is steroids. Okay, and steroids are lipids, and they are lipid soluble. They are not water soluble. And what we find is that we have one particular steroid that is so important for cell structure and function, which is called what? Cholesterol. Okay, and we've talked about this in times past, but our body makes a full gram of cholesterol every day. Very important in terms of cell structure. But cholesterol has some other functions as well, because what the body can do with cholesterol is it can take that molecule, and you have an illustration there in your notes, and it can tweak it, it can modify it, it can change some of the side groups to start making other types of steroids, and these will be hormones. And